function always exist? Let's find out by working on our second example.
Let g of x be equal to x squared minus 1 when x is less than 2 and x plus 2 when x is greater than or equal to 2. Then evaluate the limit of g of x as x approaches 2. To visualize the function, we graph the piecewise function. Now we draw an imaginary line that separates the values of x at the left of 2 from those values of x from the right of 2. Then we get the value at which the function approaches 2 as x approaches 2 from the left. In other words, we will consider the values of x which are less than 2. In this case, we will focus on the graph of f of x equals x squared minus 1. Looking at the graph, as x approaches 2, the function gets closer to this point, having coordinates 2, 3. This means that the limit of x squared minus 1 as x approaches 2 from the left is 3. This time, let us consider the values at which the function approaches 2 as x approaches to 2 from the right. Hence, we will consider the values of x which are greater than 2. With this, we shall focus on the graph of f of x equals x plus 2. Looking at the graph, we can say that as x approaches 2 from the right, the function gets closer to this point, having coordinates 2, 4. This means that the limit of x plus 2 as x approaches 2 from the right is 4. Recall that in order the limit will exist, the limit of f of x as x approaches a from the left should be equal to the limit of f of x as x approaches a from the right. Since we got different values at which the function approaches 2 as x approaches to 2 from the left and from the right, we can say that the limit of g of x does not exist. Let's verify our answer using a table of values. Note that you can choose any value for x as long as it satisfies the conditions. Looking at the set of conditions, we will consider the function defined at x is less than 2. Hence, we will be evaluating the limit of x squared minus 1 as x approaches 2 from the left. Have you arrived at the same values just as what I did? From the table of values, we can conclude that the limit of x squared minus 1 as x approaches 2 from the left is equal to 3. Now let's evaluate the given function considering the values at the right of 2, which are the values greater than 2. So we get the function having a condition x greater than 2. Hence, we will have the limit of x plus 2 as x approaches 2 from the right. Study the given table of values. Use your scientific calculator and verify the values that you see. Looking at the table, we can conclude that as x approaches to 2, the function approaches to 4. Therefore, the limit of x plus 2 as x approaches 2 from the right is 4. From this table of values, we can clearly see that the two sides of the limits when evaluated has approached different values. Remember this: if the limit of f of x as x approaches a from the left is not equal to the limit of f of x as x approaches a from the right, then the limit of f of x as x approaches a does not exist.